Alright, so the feedback was that people like having these videos. So in this section, we're talking about the multiplication rule of counting. We're talking about some tree diagrams, which are just graphic organizers. Quite honestly, they're completely optional. But most importantly, we talk about factorials and permutations and combinations. Now, permutations, the order matters. The formulas, as you can see, it's in your book, it's on your formula sheet. It's P sub n comma r, where n is the total number of whatever we're talking about, and r is what we're picking. So for example, if I have 8 horses are running a race, and we want to know in how many ways they can finish first, second, and third, the order clearly matters, because if you're first or second, you would get gold or silver. So it matters which order you finish in, therefore it's a permutation. So in this example, the n value is 8, the r value is 3, so I go ahead and I plug it in. Now you could just plug this into your calculator, get an answer, and be done with it, but you may be forced to type all of these numbers. So luckily we can use our computation skills and go ahead and work around that. So 8 factorial is the same thing as 8 times 7, 6, 5, 4, 3, 2, 1. And 8 minus 3 factorial is 5 factorial, so 5 times 4 times 3 times 2 times 1. Now what I notice is I have 5 times 4 times 3 times 2 times 1, 5 times 4 times 3 times 2 times 1, so I'm just going to go ahead and cross those out. What I'm left with is 8 times 7 times 6, which is 336. So there are 336 different ways that these 8 horses could finish this race, finishing first, second, and third. The second thing we talked about were combinations. Combinations order doesn't matter. So let's say this is just a qualifying race, and those same 8 horses have to race, and the top 3 will advance to the next race, where just those 3 will race for first, second, and third, or who cares. So this formula is what we use for combinations. N is still the same, and R is still the same, because we still have 8 horses, and we're still picking 3. And now when I go through and do the math, I would have 8 factorial over 5 factorial times 3 factorial, which translates to 8 times all of that, and then 5 times 4 times 3 times 2 times 1, that's 5 factorial, and 3 times 2 times 1 is 3 factorial. Using the same logic, I can go ahead and cancel out the 5 times 4 times 3 times 2 times 1, and the other 5 times 4 times 3 times 2 times 1. And now what I have here is 8 times 7 times 6, and 3 times 2 times 1. I know 3 times 2 times 1 is 6, so I'm going to go ahead and cancel those out, and I'm left with 8 times 7, which is 56. So hopefully that clarifies the permutations and combinations. I will be assigning you a few problems, and hopefully this video helps you out. Good luck, guys. I'll talk to you later.